Hello everyone, welcome back to my channel. I'm Shikha and today we are going to discuss about photovoltaics technology. Now, what is photovoltaics? Now, the photovoltaics technologies that are commonly known as solar panels, they are used to generate powers using devices that absorb energy from sunlight and convert it into electrical energy through semiconducting materials. As I showed here, that photovoltaics is the science of direct conversion of light to DC electricity based on the fundamental principles of photovoltaic effects. This phenomenon is exhibited in semiconductor materials. The photovoltaic effect is defined as the generation and electromotive force as a result of absorption of ionizing radiation. Photovoltaic devices which convert solar energy into electricity are called as solar cells. So that's exactly what it is like. The photovoltaic that devices which convert solar energy into electricity that are called solar cells. Now we will discuss about what is solar cells. It consists of, as we discussed earlier, that the solar cells are the photovoltaic devices only that will convert the solar energy into electrical energy, so that electricity we can use as a result. So solar cell, it consists of semiconductors in which electron hole pairs are created by absorption of incident solar radiation. The region containing a drift field for charge separation and charge collecting front and back electrodes. By this phenomenon, we are going to create the solar cells. Means this is the what exactly is going to happen inside of the solar cells while the conversion is taking place between the solar energy to the electricity. Now, development of solar cells. Time to time, there is a development that happen in the solar cells that are as in starting this first generation, that is single crystal silicon wafers. That they are the in very first they are the solar cells. Then the second generation came, that are amorphous silicon and polycrystalline silicon, cadmium telluride, and so on. Then third generation comes for the use, that is the nanocrystal solar cells and photoelectrochemical cells, PC cells, and polymer solar cells, and etc. Then fourth generation, that is hybrid inorganic crystal within a polymer matrix. These are the generations and development by the time to time solar cells. Now, types of solar cells, that is silicon solar cells, single crystal silicon cells, commonly used. In this, the crystal silicon cells, they are using single crystal silicon cells to make this solar cell. It usual efficiency is 20% and long lifetime, that is greater than 20 years, approaching the theoretical limit of 29%. Now, that in this only, that polycrystal silicon cell, this is the properties that is for this is less expensive, efficiency is usually less than 15%. Amorphous thin film silicon cells, that is thin non-crystalline silicon layers, are printed on a substrate and then lightweight and less expensive, and its efficiency is around 10%. Now, that another is cadmium telluride thin film cells. Now, this is its properties are, it's like this is inexpensive to produce and best efficiency reported as 25% its efficiency, and popular for solar panel arrays that we use in our homes. That's solar panels, that it is very popular for this. Now, copper indium gallium selenide thin film cell, it's also used. This is its efficiency, it is around 20%, and manufacturing costs are higher than the amorphous silicon thin film cells, but dropping fast. Now, the gallium arsenide multi-junction cells. This maximum reported efficiency of 42.4%, much more expensive to produce. It is very expensive to produce, and it is limited to scientific and high-cost commercial uses. So now, the advantages of using this photovoltaic solar cells, that are, it is unlimited supply of raw material, well developed materials and device technology. It is well developed understanding of physics and high solar cell efficiency, and it is well established long term solar cell stability. As well as disadvantages are there, that are low light absorption coefficient, large thickness of material required, and high cost of silicon wafers. Now, this solar panels. A single solar cell has very limited output capacity. For example, a single crystal of silicon cell output is about 0.4 volts. So cells are joined in a series and parallel to increase their output capacity, to increase the efficiency, and to get maximum output, so that we can use in our home, household sinks, or even in the research areas, or as you can see in the colleges everywhere nowadays, they are using this sunlight and for the conversion of solar energy to the electricity. So in for this we are going to join the cells of silicon in a series and parallel order, so that to increase the output capacity. For example, 36 solar cells, that silicon cells, are connected to produce a approximate of 24 volts module. So, further increase in output capacity require joining of panels into solar arrays. Means first though we will join the solar, that silicon cells in a series and parallel manners, and after that we will join the cells, also solar cell, that solar panels that we are making by the joining of silicon cells into an order, so that to increase the efficiency. After that, the components of a photovoltaic system, that is, it consists of the following components, that are first is solar PV module, and then battery, charge controller, inverter or converter, and a mounting structure and tracking device, and interconnections and other devices. As you can see in this figure, solar irradiance, that radiations that are coming from the sun, then it is directly falling into the solar panel. Then from that electric current, it is got, because of the conversion of, as we already, that this is only the basic theory, that is that photovoltaic system, that is to convert the solar energy into the electricity, and because of the solar panel we can convert that, so we'll get directly the electric current, and then it will go into the charge controller. After that it will supply it the DC power battery system, and after that it will convert for the inverter, and it will make it as AC power, so that it can be used. By this way, they are using this photovoltaic solar system, solar cells, for the conversion and to get the electricity from the natural sources. Hope you got the video and you understand the topic. Thank you so much.